Hi guys, welcome back to the channel. And today I have just pulled out of the box a Q*bert board. It's my first real, not bootleg, Q*bert board repair. First and foremost, take care of the business. I would like to give a big shout out to all of the Patreon members who are supportive of the channel and supportive of this Q*bert repair documentation video. Thank you so much. Alright, so we're just going to give this thing a once over. The battery's been replaced, I see. I see green. Green in here. Green in here. So our battery did leak onto this. The corrosion kind of seeped in just a little bit, not bad. But if I go ahead and remove some EPROMs, that one doesn't look so bad. Alright, I see green in that one. Yeah, pretty good green in that socket. And I'm sorry about the squeaky light. Yeah, let's see what we got. Lots of green, green, green. All of these have to be replaced. I don't believe this is populated, but I'm going to remove it anyway. The socket right here, because it's got green in it, and I want the green stuff off the board. And none of this looks damaged at all. It's just these. It's kind of seeped into these ROMs. I don't see any green over here. A little bit here. Corrosion. Little corrosion here. And we got a lot of RAM, which that can all be tested easily. Okay, we have a diode on the back side of the board. It's probably for blocking the recharge. Yeah, there's a diode on the back of the board right there, and that has to be for blocking the current back to the battery when it's in operation, so that it doesn't blow up. Well, that's good. This looks like it was cleaned up fairly well. So I think we're good to go here with this. So right off the bat, I'm going to replace these sockets. The ROM sockets, I'm going to remove this socket. These four parts right here are a little nasty looking. These four parts right here, I don't know, I might leave that, I might replace those, I don't know. That's got to go. This one's unpopulated, so I'm just going to remove it and not even bother replacing the socket. I'd like to remove and replace that. Anything that looks like that. And there's specks of green in these. So these are all getting replaced. That looks okay, and I imagine that once we get over to here, everything's probably okay. So, yeah. So we'll do that, and I will just go right ahead and do some software and RAM checks. I can dump all of this ROM and verify it. I can verify all of the RAM chips. All of them on the board can be verified to be good. And then once we get we know our software is good, we know our RAM chips are good, then we can move on to other things. So I do have an 8080 pod. I can put an 8080 pod on this thing and test everything out. So yeah. All right, cool. let me do a little maintenance and then we'll come back. Okay, yeah, funny selective corrosion areas. This socket needs to be replaced. The other RAM sockets look to be okay, but this one I don't like. It's just corrody doodle inside of there. And this CPU socket is terrible. That's the worst one of them all. That's not battery corrosion. That's just got to be dampness corrosion, like air corrosion or whatever. You know, there's no way battery corrosion skipped everything else and just came up. Well, I don't know. I don't know. This is really strange because there's like corrosion over here, but that could just be environmental corrosion, really. Don't know. Strange, but yeah, that's terrible. And I see some green. I don't know if that's like paint or what is that. Let's remove this chip. No, someone replaced that. You can tell, and somebody painted or whatever there. That looks fine. Yeah, this chip has been replaced. So, okay. Yeah, so these got to go. That one, this one. Let me. Oh boy. All three of these got to go. This one's the best looking of the three. Yeah, I'm just going to replace. See, that one's got green fuzz in there, and this one looks okay. These, do they look okay? Those look okay. These will clean up. And down here, those will clean up. They look fine. Yeah, so these are good. Oh boy. Corrosion. I'll replace these two. That's a lot of socket replacement. That one's got some corrosion in it. This one's not as bad, but why not? At this point, why not change that one as well? This one has to be replaced. So we're going to replace these two, these three, this one, and these four, and this one's just going to get removed. And I'm going to remove this corroded socket. So lots of work to do. And I'll verify all of this. Okay, so I dumped all of these ROMs, and the three program ROMs, two of them come up as Qbert early test version or something like that, and one of them comes up as nothing. So one of them is not even a Qbert ROM, and two of them are the early test version or something like that. So I'm going to erase all three of these and program them with regular wide release Qbert program. So yeah, the other ROMs were fine. The all of the graphics ROMs were okay. It's just these. It's going to be fun cleaning this stuff off. Yeah, so I'll go ahead and do this. Get these things erased. I've got the regular Qbert ROMs loaded into a disc, ready to go. And it's going to take me a while to get these cleaned really good, so I'm going to go do that. And one of the RAMs, one of the 8209 RAM chips, one of those was bad. So yeah, those are like sprite data registers or something like that is what those are used for. Something like that. So yeah, one of those was no good. All the other RAMs were fine. And all the other ROMs were fine. It's just these ones. So we'll get these changed out and be good to go. Qbert progress. Okay. We have removed all of the old junk sockets and parts to clean this corrosion off. I've erased those ROMs. Whether they'll reprogram or not remains to be seen. So we'll deal with that when we get there. Next thing I'm going to do is get a cup of coffee, and then after that I'm going to have to lightly sand down some of this corrosion off of here, re-tin the board where the copper's bared out, and then repopulate. I'm going to wash this board really good too. It's pretty dusty and dirty, so we'll get it good and clean. Oops. I forgot these. Yeah. Yep, those got to go out too. So I'll get these removed as well. And then that's it. So let me get the gun back out, heat it up, remove these, then do all that aforementioned work, and I'll be back. Alright, well, and I thought I was done. I removed those two, as I said I was going to, and then I remembered these three were corroded, so I removed these three, and then after looking over here, this one was corroded, so I had to remove that socket. So I have removed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sockets. I've removed 14 sockets and removed a bunch of parts as well. So I removed the battery holder, because I'm going to relocate it. It was like this. I don't want it to be like that. I would rather it be, no, that ain't going to work. I would almost rather it, yeah. Yeah, I think we are going to have to do that the way that it was. That's okay. It had to come out anyway because I need to clean this. So we'll put it back the way that it was and then run our diode. But I'm replacing the diode. It was just using a regular rectifier. And really you want to use a Schottky diode because it's got a very much less of a forward voltage drop, whereas a standard rectifier is about 0.6 of a volt. A Schottky diode is about 0.25 to 0.22 of a volt ish. So 22 millivolt drop versus 600 millivolt drop versus a 220 millivolt drop just means that you get about 400 more millivolts of voltage to push the current through that battery circuit. So it just allows for a more reliable battery backup circuit. So we'll do that, clean this thing up, lightly sand off the corrosion, re-tin where needed, wash the board good, repopulate with sockets. I gotta burn the software, the program software, and then we'll be ready to test. So there's still a lot of work to do before we're even ready to plug this thing in. I don't even have my harness made yet. Here's my edge connector that I'm using. And it's actually 30, not 28. So, yeah. Strange edge on Cubert. It's a 30-60. Weird. All right. Well, let me get all that stuff done. Go get a coffee. I'm taking a break after all that. Go get a coffee and then come back out, and I'll do all that. All right. Look at this beautiful Cubert board now. Nicely cleaned. All that corrosion cleaned off and re-tinned. And over here, this is all cleaned and re-tinned. Just need to repopulate some parts. All the sockets, I got the back of the board cleaned really nicely. Ready for new sockets. Looking great. Right? So we'll just have to do some repopulating. I got my ROMs burnt. The original EEPROM chips that were in there were fine. I was able to erase them and reprogram them, no problem. So this is the mass release normal Cubert software set, program set. So good to go there. All right, so all we got to do is start repopulating sockets and little parts that I had to remove to clean. This socket is not getting replaced. These two sockets I'm not going to replace because it only uses 3 for this. So I'll replace those. And yeah, that's it. I mean, then I have to replace everything else that's removed. So I'll go ahead and do that, and then I got to create my harness. I got to make my harness according to this. And I think I'm going to go and get a good Cubert schematic printed off on nice cardstock 11 by 17, and just to have and put away. And yeah, so we'll be ready to fire this baby up. Be pretty cool. Alright guys, all of that maintenance work is complete. Got the battery holder put back in. Got all these parts here. That's a 5.1 volt Zener diode. Yeah. All the sockets are in. New sockets everywhere. Here. That one. 3 program ROMs. That guy right there. CPU. And these parts have been replaced. And on the back I got the Schottky diode. It's the same diode that's used in the battery circuit of Williams Defender Robotron to protect the batteries from current backflow. Yeah, so you have the cathode blocking from the rail. Yeah. And I'll show you the difference. Bear with me. Okay. Put this here, you'll see the diode drop difference. Let's get on that, make sure you can see that good. How's that? Can you see it? Okay. Trying to get everything in the shot. It's too bad that don't light up. Let's move it up a little bit like that. There we go. You'll see the diode drop on this Schottky barrier diode. Oh, right here. It's just under 200 millivolts as opposed to 600 to 700 millivolts in a regular rectifier. That just allows more voltage from the battery to move the electrons around in that battery backup circuit. Yeah, 200 millivolts. So that is why you use that kind of battery. Because a CMOS chip, a CMOS battery backup is, I think the power needs to be about 2.2 volts or something like that to power it. And this is a 3-volt battery. It's a 3-volt battery. So you're losing only 200 millivolts. So you're going to be at about what? 2.8 volts, 2.7 volts or something like that. To whereas if you're using a regular rectifier, you're losing more voltage. So you're kind of on the border of it not working, you know. I want to clean that. There's some solder flux in that battery holder. I want to clean that out, put the battery in it, and then we'll measure the actual voltage coming out of this into that circuit. Okay, so I've got the battery holder cleaned up and the battery put back in. I'm going to turn this fan off and we'll see the actual voltage coming out of the battery and through that diode and into that circuit. So here we go. It is 3.08 volts. So yeah. And it's actually 3.1, so there's really no discernible drop through that. Yeah, so there you go. Now that is being powered. And what is the battery backup in this? Where does that go? What does that power? I'm going to have to look at that and see what chip that actually powers. What is the battery backup RAM on this board? Curious. Alright, well that's that. This thing is good to go. I mean it's ready to populate with the chips now, and I got to finish my harness and then fire it up. Be back. Okay. So I've got it all hooked up. I got my harness made here, and I put the CPU in here. It's in the correct orientation. It's pretty exciting, isn't it? First fire up. I've double checked that my power is hooked up correctly. So let's go ahead and switch it on, see what happens. Alright, nothing popping, that's good. It's working. It looks like it's working. Maybe. Let's see if it runs through its running stuff. It's credited. Maybe it's on free play. I'll have to look at that, the dip switch settings. Let's just go ahead and put the camera over here. That's first fire up, guys. With just all that maintenance that I did and the software. Remember, the program was no good. So I've got controls hooked up so I can plug in my controller and play Hubert. Alright. I do want to check the voltage really quick, just make sure I'm close to 5 volts and not way over or anything like that. .76. I'm going to move it up a little bit. You know, just a little bit. It don't need to be right on. There we go. 495. I'm going to leave it right there. Okay, let's do this. Uh-oh. It's starting to play, but then it stops. I have to look at the... I need to know if I've got this wired right. Yeah. Weirdness. So, I need to double check my wiring, because there's... I think there's like service switches and stuff that actually need to be wired up. I'm not exactly sure. So I'll have to look into that. Yeah. Cool though. I mean, it looks that looks good. I don't know what's up with my dip switches, so I'll go ahead and I got to do a little research, and I might have to wire in some micro switches to this, or just kind of look at the wiring diagram and see how this thing's supposed to be wired. Let me do a little bit of looking and I'll be back. Alright, well, I was actually looking at the schematic here and started probing the CPU, and I found out the reset line is pin 21 on the CPU. And that comes from this clock generator chip. So if we look at pin 21, we see that action on there? It's resetting. Okay. So if we look at that chip right here, this clock generator chip, our inputs are a 15 megahertz signal at 16 and 17. 16 and 17. Here's 17. And it's way too fast. So let's, I don't know if this is the right way. Yeah, let's try this. Oh, nope. That's not the right way, I don't guess. Oh, well, I do have to move the trigger way up. There we go. There's a 15, close enough. And on the other pin, same thing. So that's good. Okay. And let's move our trigger back down. So we know that we're getting a reset on pin 21 right there. Well, let's look at this clock generator. Okay, there's our signals going in. All this stuff is grounded. There's only a couple more signals. And we have a reset. So this thing resets. This is a... Is that an OR gate or a not OR? I think it's just an OR. and one of the inputs is high all the time. Oh no, it's not. It's low all the time. So this chip right here is a knower. Yes. Okay. So yeah, both of them need to be 1s to get a low, and that's not desired. We want 2 zeros. So we do not want pin 15 of the 161 watchdog timer to go high. Once that goes high, that'll go low and reset this thing, and it resets the CPU. And that's what we're seeing. So it's like, okay, pin, the clock comes from the non-maskable interrupt on the CPU. So it's just performing a timing loop where this is outputting a signal here. No, it's not outputting, it's just vertical blank. So vertical blank is clearing or clocking that watchdog timer. Now this other signal is what I'm interested in. Clear, pin 1 of the watchdog timer A3. Pin 1, A3. Clear. We should be getting a clear, and we're not. It's high all the time. No clear. So that tells me that this signal is not doing its job. See, there's a watchdog clear right there. Now we got to follow, where does watchdog clear come from? There it is, watchdog clear. Comes from B9. Y0, output 0 of B9. So let's look at that. B9 output 0 is right here and right here, and that is high all the time. Okay, I'm just messing around. Okay, high all the time. We should be getting a clear. Let's look at the inputs to this thing. It is addressed right here. It's addressed by the address bus. So it is a software driven interrupt. It's a software driven signal. So if we look, we have, there's address going crazy, address good, you know, address looks good. Now we need enables, and that's going low. This is a low enable, this is a low enable, and you got a high enable here. So all of our enables look like they're doing stuff, and our output is high, high, high all the time, high all the time. They're all high all the time. Every output. So this thing isn't doing anything. So either it's a timing issue to where this thing is never enabled. You know, all of the enables don't. You need to have 2 low enables and a high enable at the same time for this to be enabled. And at that point, when the enables line up correctly, whatever's on the address input is the line that will go low. If it's 7, you know, 1, 1, 1, which is 7 in binary, then the 7 input will go low. Now, I have a 138 right here. And if I put this 138 over this chip, like so, and kind of probe around on it, look what we see. You see that fighting there? You see that thing fighting that? It's going about halfway low every now and again. See that? This chip is no good. This 138 is not sending the clear signal to that 161. So we need to replace B9. Let's do that and come back and see what we get. hopefully this thing will take off and actually run once the reset is being cleared. This thing right now is in a constant state of reset because it's not, this thing is counting freely. It's not being cleared at all. The reset counter is just counting freely and resetting this at a given interval, whatever the count is in frequency. So yeah, it's just running rampant. So we need to stop that. We need to get this chip replaced right here, B9. Okay, part replaced, and you can see I had to cut down an 18-pin socket. I could have just left it on and removed the pins, which is what I should have done, but I didn't. But I replaced that part, and it is running. Bert. So let's hook. I'm going to put the camera up and we'll play the game and make sure it plays through and all that good stuff. Alright, here we go. We'll go ahead and coin it up. Oh, I got to hook the joystick back up because I removed it. Okay. So let's coin. Yeah, coin worked, and start. Excellent. This is going to be tough sideways. Yeah, this is hard to do sideways. Oh! A funny story, this game, the voices, oops, darn it, way back in the day, years ago, my kids were terrified of this game because of the voices. They always thought the voices were creepy. This is such a cool game. This is a great game. Yeah, but they used to be freaked out by the voices in this. Yeah. There you go. Hubert. Works. I'll let this thing sit out here and run for a while. Shake out any ghosts. It's good to let them go for a few. Oh, they need to go for a few hours. Just if there's any ghosts in the machine, it'll knock them out, and then hopefully that's it. So wow, we did a lot to this one. We replaced a bunch of sockets, got rid of all the corrosion off this thing. Had a bad chip here, had a couple of bad RAMs in the board. The ROMs needed to be reprogrammed with proper Qbert files. Cleaned this thing up really nicely. Yeah. Excellent. So yeah, big shout out to all Patreon supporters. I think we picked up a new one after the last video, and I do appreciate that. I mean, it helps with putting out all of these documentations of what problems you might run into and all that good stuff. So once again, everyone, thanks for supporting the channel, and we'll see y'all on the next Classic Arcade Repair. Bye for now. Shout out time.